This is part 2 of lesson 9.3, Infinite Sequence. And in this lesson, we're going to look at two very specific sequences that you probably have seen in algebra, but also have very important significance as we move forward working with sequences. And these are arithmetic and geometric sequences. So I'm going to start by defining them, and then we'll do some examples working with them. So the first definition is for an arithmetic sequence. So a sequence and we're going to define it as A sub n is an arithmetic sequence if it can be written, in the form so it's going to look like this. So we have our first term, A sub 1. And then we're going to take that term and we're going to add some constant to it. And in the next term, we'll add the constant again. So it'll be added twice to the first term. And then for the next term, we'll be adding that constant 3 times. And so on, like that. And so eventually, the nth term will look like this. I'm sorry, that's very messy. It's hard to read that. Let me do it in a different color. We're going to be adding dn minus 1 time is what we're going to be doing. So that's for some constant d. And your A sub 1 is your first term. And we find d as the common difference. So it's going to behave in a linear fashion. Okay, so we have two formulas we work with here. We have our recursive formula, which is what I defined the first few terms as, and that looks like this. A sub n equals A sub n minus 1, and then you add a constant. So you take, if you want the third term, you take the second term, and you add that constant. And of course, this is only going to work for n greater than or equal to 2. And then we have our our explicit form. And that's going to look like the general term that I wrote up there, which is going to be the first term plus n minus 1 times d. And let me pull that over because I think it's off the screen a little bit. There we go. So that's what that's going to look like, the two forms. And there's no E on explicit. There we go. All right, so let's do an example with this. So number 21 on page 656 in our textbook, we are given this sequence, 6, 10, 14, 18. So what you need to do first is find the common difference. So you just have to see how far apart those numbers are. And in this problem, we're given that this is an arithmetic sequence. So we know that there is a common difference. So in this case, the common difference is 4. And then the next thing we want to do is find the 10th term, which I think in the problem should be like the fourth thing to do. So we are going to, first, before we do that, is we are going to write a recursive formula and then an explicit formula. So we'll do those two first, and then I'll come back and give the 10th term. So the recursive formula is, I'm going to take the term and take the one before it, and I'm adding the common difference, which is 4. Okay, and then the explicit rule is going to be the first term, which is 6 plus n minus 1 times 4. And if I simplify that, I get 4n minus or plus 2. If I distribute the 4, and then simplify. So now what I'm going to do is I'm going to use this formula over here. So I'm going to take 4 times 10 plus 2, so I get 42. Okay, so the other sequence we're going to talk about is the geometric sequence. So for that one, starting with the definition, we're going to have a sequence again. My a sub n, and it is a geometric sequence if it can be written as, now for this one, we are going to have a first term, and then we're going to, excuse me, we're going to multiply it times a constant instead of adding. And so then for the next term, we would have multiplied it twice or squared it, and for the term after that, it would be cubed, and so on. And what you're going to notice is that we're always multiplying that one less than whatever term we're on. Like that. Okay? So again, A is our first term. And R is called the common ratio. And we want to remember that this R has to be non-zero. Doesn't make a lot of sense for multiplying by 0 because we don't have a sequence then. So then we have a recursive formula, which is shown as the first couple terms, and that's going to be a sub n is going to be a sub n minus 1 times r, and of course that's for n greater than or equal to 2. And then our explicit formula is going to be a sub n equals a times r to the n minus 1. All right, so then we have the special sequence that I talked about in the last video, which is the Fibonacci sequence. And this sequence can be defined, and this is defined recursively Okay, we define A1 as 1 and A2 as 2. Oh, is also 1. And then, so all the other terms are a to the n minus 2 plus a to the n minus 1. And of course, this is for all positive integers greater than 3. Because we need the first two terms. We need 1 and 2 to create all the other ones. Okay, now doing an example with a geometric sequence. So let's say we're starting with this sequence. We have 2, and then 6, and then 18, and then 54, and sometimes they're more obvious than others, but you can always find your R by taking a term and dividing it by the previous one, so you get 3 if you don't see it. And so part B asks for a sub 8, which again I won't do to the end. I really want my recursive formula first. And then my explicit formula. So my recursive formula is going to be a sub n is going to equal a sub n minus 1 times 3. And my recursive formula, my explicit formula is going to be a sub n is going to equal 2 times 3 to the n minus 1. So that's the one that I am going to use here. So a sub 8 is going to equal 2 times 3 to the 8 minus 1 power, which is 4,374. All right, and then our final example is, we have 2 bar here. We have another sequence for an arithmetic one, and then we're going to graph a geometric sequence. All right, so what we're supposed to do in number 29 is find, it says the 4th and 7th terms of an arithmetic sequence are -8 and 4 respectively, which means that you do them in the same order they were originally listed. So the 4th term is -8 and the 7th term is 4. So we are supposed to find the first term and the recursive rule. Now, in order to do that, we need R as well. So here's what we do. We're going to set up 2 equations with 2 unknowns. We have A1 and RD, and we're going to solve them like a system of equations and create our equation. So here's what we know. We know A4 is equal to -8, and that is going to be A1 plus 4 minus 1, because we know n, times D. And A, so that is not AN, that's A4. And A8, A7 equals 4, and that is A1 plus 7 minus 1 times D. So here are the 2 equations we're working with. We're working with negative 8 equals A1 plus 3D. And we're working with 4 equals A1 plus 6D. So solving these, if I use elimination, I'll just change the signs of all these, and I get negative 12 is equal to negative 3D. So D equals 4. And then I can take either one of them, of my equations, and find A1. So I'll just use the first one. So I have negative 8 equals A1 plus 3 times 4. And so I get negative 8 equals A1 plus 12. So A1 is going to equal negative 20. So now what I can do is I can write the recursive rule. So I have A1, that's part of my answer. And then the recursive rule is going to be A sub n equals negative 20 plus, oops, I'm writing the explicit rule. I apologize. A sub n is going to equal A sub n minus 1 plus 4 for n greater than or equal to 2. All right, and then finally, graphing a sequence. So you can see how they are related to functions. So we're going to graph A sub n equals 2 minus 1 over n. And you can go ahead and put this in your calculator. So putting it under y equals, you could put it under like any rectangular equation. And then if you want, you can write down your points here. So there is no point at 0, but you want to make sure you're counting by 1, starting at 1. So I have 1, 3 halves, 5 thirds, 7 fourths, and so on and so forth as you go down. And then you can just plot those points. And if you look at the graph here, you can get a sense. I only have my window from x equals 0 on. But what you want to remember is that this is not a connected graph because there's no points in between 1 and 2 because we're using integers only. Whoops. So when I go to graph this, I'm going to have these points. So at 1, I'm at 1. And then it's going to look kind of like this. I think I'm up too high. I think it skirts right along 2 is what it should do. So it should look like that. And you don't want to connect them at all. Okay? So that's what that looks like. Okay, so that ends our notes for section 9.3.